A high-voltage line is protected with a line protection associated with the signaling system. This protection should be tested in real time. For this, 2 CMC test systems are used. To test main and backup protection at the same time, 4 3-phase systems are simulated. That is, 12 independent signal generators are controlled, 6 times voltage and 6 times current. To design a test with 2 remote test devices, it is necessary to ensure that the fault quantities are output simultaneously using a synchronization. Synchronization via GPS satellite system is the method most often used worldwide. Accuracy plays an important role for synchronization. A synchronization fault of only 1 millisecond would result in a fault of 18 degrees at 50 Hz or 22 degrees at 60 Hz nominal frequency. With the GPS receiver from Omicron, we get an accuracy of 100 microseconds maximum error. The CM-GPS can directly be connected to the CMC. As it is part of the test system, no additional wiring is necessary. The software for configuring and controlling of the GPS receiver is integrated in the test software. This small and handy GPS receiver, which has been developed especially for the testing of protection systems, is the only one of its kind. Along the protected line, the behavior close to the set reaches is of special interest. Accordingly, we define our test points. For example, 5% before and after the set reaches. Each of the 9 test points we test with 3 different fault types: single-phase, 2-phase, and 3-phase. With this, we get 27 sequences, which we embed into our Omicron Control Center document prior to the test. Had we used 7 different fault types, 3 single-phase, 3 2-phase, and a 3-phase fault, the test would be even more complex. We would get 9 times 7, that is 63 sequences times 4 states, resulting in 252 states. Each of these sequences consists of the states synchronization, pre-fault, fault, and post-fault. This automatic test procedure is created for each of the 2 stations. In each of the more than 60-mile distant stations, a test team is located which builds up the connection via modem. Controlling of both test systems is performed from one side only. To support this remote control, we use a remote control program or any type of communication between 2 PCs. With this new method, the test system on the other station can be evaluated without time-consuming inquiries, and corrections of the time behavior of the test can be performed from one single location by one single engineer. Now the following sequence is run through at both locations. Connect the CMC and CMS with the test object and switch on all devices. Connect the CM-GPS with the CMC and the aerial. Start the CM-GPS software and wait for locking. Load the Omicron Control Center document with the automatic test procedure which was created in the office earlier. Start the remote control program. Call the other station and establish the connection between the 2 PCs. Allow the master PC to access the test software of both systems. From the master PC, the following tasks have to be performed for both sides. Set the start signal and the pulse interval. Start the test procedure. After the start, the test of the 2 locations can easily be monitored from one single screen. If no errors are detected, the test lasts for about 10 minutes. With conventional testing methods, a test of this complexity may easily take several hours of intensive work. of several experts on both test locations. This test method can not only be used for tests with the Omicron state sequencer. The fault simulation may also be performed with settings in the distance modules, or playing of real faults recorded with fault recorders and stored in ComTrade format, or EMTP or ATP simulations in the software module Advanced Transplay. Let's summarize what we have just seen. With this test, we tested the main and the backup protection simultaneously. The test was remote controlled from one single PC. The whole preparation was done offline in the office. The test was performed in a fraction of conventional testing time. The test procedure created can of course be used for conventional routine tests. The presented method opens up many new possibilities for protection testing. It may play an increasingly important role in connection with subjects like remote analysis or customer support. It enables experts to support test teams without the need for their physical presence in the test location.